So now we're going to consider double auction markets. In fact, we're going to try to interpret what goes on in these double auction markets through the supply and demand model, or what we have called the competitive equilibrium model. You may have seen double auction markets in a video, or participated in one, or seen one in class. So the basic idea is that you have both buyers and sellers bidding. That's why it's called a double auction. Both buyers and sellers are in the market. And their buyers are trying to get things, they're trying to buy things in the market, and they get marginal benefits from what they buy, and their marginal benefits are represented on cards. There's also sellers, they're the firms trying to sell things, and their marginal costs are also represented on another set of cards. The idea in this market is that buyers and sellers are going to interact like in any other kind of market, and we're going to see what happens. Buyers, of course, are going to try to get a low price, get the lowest price they can for what they're getting in the market, but they'll be competing with other buyers in the market. Sellers are going to try to get the highest price they can for what they're producing, but they're going to be competing with other sellers in the market. So that's the nature of the competition, and you can see that when you watch or participate in these kinds of markets. What's going to happen after a while of open bidding, it's going to look chaotic as people are trying to buy or sell a certain amount of the good, but the market will settle down to a price and a quantity sold. We're going to consider a situation where we have run or examined a bunch of these double auction markets, 15 in fact, because we want to see how they work compared to the model. So we don't want to just do one, just do two, we'll do 15. Of course we could do more than that, but 15 is kind of a nice number to examine how it actually works. So our interpretation here of what goes on a double auction market is this competitive equilibrium model. And recall, in a competitive equilibrium model, there's a market supply curve and a market demand curve, and there's a prediction that the price and quantity will be at the intersection of those two curves. But in addition, the market supply curve is derived from the marginal cost of each seller. All the sellers' marginal costs added up, you get the market supply curve. Similarly, the market demand curve is derived from the marginal benefits of each buyer. Add those up, and you get the market demand curve. So in the double auction, we know exactly what the marginal costs and marginal benefits are for the sellers and the buyers respectively, so we can examine those. So let's first consider the sellers and derive the supply curve. So these little boxes at the bottom of these graphs represent these cards where the seller's marginal costs are located. So for example, if you look at seller A has a marginal cost of 5 for producing one item. For 2 items, it's 10. Marginal cost is 25 for 5 items. So that's seller A. Seller B is a little different, marginal cost a little lower, 4, marginal cost for 1. And then as you go across, you see seller C, seller D, and seller E. Seller E has only $1 marginal cost for producing one item. So that's what we have noticed, is that you have this marginal cost for different firms, and these sellers are trying to represent different firms in this double auction. We can derive the supply curve for each of the seller simply by examining the marginal cost, and that's what's shown in the diagram above each of the boxes. And the horizontal axis of each diagram is the number of items produced and sold, and the vertical axis is a number. It'll be a marginal cost, and that's where the supply curve comes from. So the dots are the marginal costs. We just plotted those dots. So for example, for seller A, you can see how they go right up the graph. And then the lines that are shown there, the green lines, that represents the amount of supply at each different price. So for example, you can see as the price rises, you can imagine the price going up on the vertical axis, the firms are willing to be supplying more because their marginal cost can be higher. So we've derived this kind of curve many times before, and now it's an actual supply curve for seller A, that person that's in the market and has that particular card to describe what it's supposed to do. Same with seller B and the other sellers. They're slightly different, as you can see. Now, in this case, there's 5 different kinds of firms, 5 different kinds of sellers, all have different marginal costs. So that's quite like the real world. But we would like to just make this so that more people can participate, or that we can have more than 5. You could have as many as you want. So what we'd like to do is assume that there's actually 10 sellers, not just 5. But to make it easy, we'll assume the other sellers, sellers F through J, are just clones for A and E. So effectively, you have two sellers in the market that look just like seller A, and seller F, etc. And we want to notice that because the market supply curve is going to be summing up all 10 people, A through E, F through J. So that's the supply. To get the market supply curve, we want to add all this up together. So we take for each price how much each seller is going to be selling, willing to sell, based on its marginal cost, and we just add them together, adding horizontally. So you just flip back and you look at the individual supply curves, you can see what's going on. So suppose the price is 1, in this case, suppose the price is 1. Then over here you see that seller A is actually going to sell nothing. Same with seller B, seller C, seller D, but there you get seller E is going to supply 1. And there's 2 people look like seller E, so the total supply, quantity supplied in the market for this particular case should be 2. And if you look over at the market supply curve, that's exactly what it is. You see, in this case, when the price is 1, you have 2 items supplied. The scale is 2, 4, 6, 8, 10, etc. So that's 2. And you can do the same thing at any price. Just go do the same exact thing, and as you do that, you'll see that as the price goes up, the quantity supplied goes up just like any market supply curve. So we derive the market supply curve from these individuals. Now let's consider demand. So second bullet here reminds us that the market demand curve is derived by adding up the marginal benefits, of each buyer. Okay, so let's do that. So here are the buyers. We have buyer A through buyer E. Buyers, of course, have marginal benefits from the product, and we represented that on these little cards. So for item 1, buyer A's marginal benefit is 25. For a second item, it's 20, and so on. You can see the marginal benefits declining. Same with buyer B. Of course, buyer B is somewhat different than buyer A. Buyer C is different, but they all have their marginal benefits represented on these cards, and they all decline. They're just different values, which trying to replicate reality, all people aren't the same. Just like in the case of the sellers, we'd like to have more than just 5 buyers, so let's assume that there are 10 and that the other 5 are just clones of these first in the picture. So there's really twice as many in the picture, but the others look exactly the same. So to get the market demand curve, we just want to add these horizontally as well, and so if you consider different prices, so for example, look in the picture, you'll see, just for example, if the price is high up there at 25, that A is going to quantity demanded 1, but then you cause nothing over here, nothing over here, nothing over here, and so the total is going to be 1 for buyer A, and there's going to be buyer F who looks just like buyer A, so the total is going to be 2 in that case. And if you go over and you look at the market demand curve, you can see at a price of 25 up there in the upper left, the quantity demanded is 2, and that's 2 on the scale. And then in this case, as you take the price down, the quantity demanded will go down as it's shown in this picture. As I should say that reverse, as the price goes up, the quantity demanded goes down. It's a negatively sloped line, as you can see. So the idea is just add it up again. Now, what we have is a supply curve and demand curve that describes these individuals. They might not know anything about these curves. They're just in there, they're going to try to get the best deal they can to get the low price or high price, depending on whether a buyer or a seller. But we have a prediction based on this model that we've been working at, that as they interact, however they interact, there's going to be a price that the market comes to and a quantity that's transacted, both bought and sold. And in this case, you can see the price is going to be $13, and the quantity sold about 26. Okay, and that's as if each market has, if there's exactly 20 buyers and sellers in each market, in this market, and the 26 is at the intersection of the 2 curves. Okay, so now let's see how well does it work. Well, we'll have these 15 different markets that have been conducted, and we kind of have the results of the markets. And you can sort of get a sense of what might happen by looking carefully at this diagram. What this diagram does, it just combines what we did before. It's small because we're trying to get them all in the same picture. But in the middle is the supply and demand curve that we just derived there. That's in the middle of the picture. Over on the left here are the marginal benefits or the demand curves for the individuals, and over on the right, the marginal costs. And we've drawn in a price here at the, there it is, that's the equilibrium price that we're predicting is $13. And if you go across, you can see that the 26 that's produced, you can see who's producing them. So at a price of 13 right over there, you can see that the quantity demanded at that price is 3. It's also 3 for that guy. It's also 3 for that guy. It's 2 for that guy and 2 for that guy. And there's twice as many of these guys in the market, so it's 3 plus 3 plus 3 times 2. There's your 18, and then you have 2 plus 2 times 2, which is 8, so it's a total of 26. So 26 are being bought. That's just who's buying them at that price. And you go over here, and you can see who's actually produced them at that price. So there's your 13, and you can see that guy's producing 2, that guy's producing 2, that guy's producing 3, that guy's producing 3, that guy's producing 3. And so the 3 plus 3 plus 3 plus 2 plus 2, all multiplied by 2, because there's twice as many, gives you the 26 again. So that's what the model's predicting. It's predicting the total in the market plus basically what each person is consuming or producing. Now, let's see if the model works. We're going to do this calculation, this simulation in the markets for many different times. So our prediction is the price is 13, the quantity is 26. If there's 10 buyers and 10 sellers. So we do these 15 different markets, see what happens, and let's take a look at the results for a particular experiment, a particular time this was done. You can see markets are named by individuals who happen to lead the market to make sure everybody is playing by the rules. And the price, you can see, is in the first column. That hovers pretty close to 13, not always exactly 13. And the quantity is in the other column. It's not always 26, sometimes 26. Generally, when it's lower than 26, it means that fewer than 10 buyers and sellers were in the market. In that case, the curves were shifted over, and so the quantity is less as a result. But you can see in this case, since the price is very close to what was predicted, the quantity is close, lower when there's fewer buyers and sellers in the markets. The model works pretty well. It's not perfect, but after all, it is only a model. Let's do one more thing to see how this works. Let's suppose that we change something in the market. We say, okay, suppose costs are higher for those sellers. Suppose their marginal cost shifts up. In particular, suppose the marginal cost shifts up by $6. You could think of this as if they have to pay a tax of $6 every unit they sell. So this will shift up the individual supply curves by $6 because marginal costs are up by $6. It will therefore shift the market supply up by $6, and you get a new intersection. And you get a prediction that the equilibrium price will be up, but be less by $6, and you get the equilibrium quantity down. Let's see why that's the case. So that's the original one with the original marginal cost curves. This is the picture when you get, it's coming up on the slide slowly. This is the picture you get when you add $6 to each marginal cost. And you can see in this case, there's just an upward shift by $6, and the difference between those two supply curves vertically is $6. Old supply has shifted to new supply because of the tax, and see our prediction is the price is going to go up. Note that it doesn't go up by as much as the tax. It goes about $3 in this case to around 16 or so, where the tax and the marginal cost rose by 6. And one of the reasons for that is the quantity actually declines. You move along the demand curve. And let's see if that actually happened in the market. Well, here's the results in this case. It's the columns over on the right, and you can see, yeah, the price is high. It's, well, for the first Jesse's group there, it's exactly as predicted, $3 higher. But generally speaking, it's higher than it was in the case of without that. So it's almost exactly as predicted by the model. And you can see the quantity sold is also down by a certain amount as well. So again, the model generates some pretty consistent results that are close to what's being predicted. The prediction of the model is pretty close to what has happened in the market, and that's a demonstration, if you like, of how accurate a model can be in this circumstance. It gives you some sense in which, when you apply a model like this to other situations where there's competition and there's buyers and sellers, not just one on each side of the market, that you're going to get similar results. Thank you.